Hello students, good evening, welcome to the Yupp Master. Today we are going to deal the interesting topic, that is the dimension analysis of a physical quantity. So if you are going to take that dimensions of length in one dimensional, let's see. Yeah, we have taken that an object which has been placed 1D, that is L, its length is going to be identified along x-axis, it is very clear. Now, if you are going to take that, yeah, this is length L, 1D, we are taking that, this is a one-dimensional view, this is a two-dimensional. Let us see that. So it is going to be two-dimensional and we are going to take that parameters, length and breadth, we are going to take that. So here we are talking about that, this is the case, we have to take that area. This is the case, we are going to take that length, and again we can go for three-dimensional view, that is we can take, yes, so we can take that volume, so it is very clear. Now, we are all going to discuss about that, the dimensions of a physical quantity, it is going to be identified if we are going to take that the base quantity power has been raised to some value. Here length, it is going to be identified L, it is going to be identified L square, it is going to be identified L cube, right? We can know that. This is very important to, so the dimensions of length, this is the dimension, yeah, we can take that. Of length is 2. The dimensions of length is 2 in case of area. Here the dimensions of length in case of 1D, we are going to take that, this is 1. Here the dimensions of length in this area, just we can take that. If you are going to take that volume, its dimensions are going to be identified 3. Now, we will take that, this is the dimension. So, we have taken that L is a one quantity, its power has been raised. Power has been raised, that its power is going to be raised to a particular value, that is going to be taken. Suppose if you are going to take that power has been raised to 1, 2, 3. So the number that gives the dimension of that physical quantity. If you are going to take that physical quantity, length is a one physical quantity, let us assume. So in fundamental quantities, we are having that mass, length, time. These are all independent quantities. Suppose you are going to take a one physical quantity, its power has been raised to a particular value, then it is known as dimension. It is very clear. Now, if you are going to take that area, volume and all these things. Suppose if you are knowing this parameter, right, now while you will taking that density, while you are going to take that density, you will find out that its dimension is going to be taking as the formula. What is the formula for density? Density is equal to mass by volume. Just you can take that. Now, if you are going to take that, just you can observe that. If you are going to look into that matter of that density, it is going to be taken yes. Let us go for this fundamental quantities. Please have a look. Let us assume that if you are taking that length and area and volume, all these parameters, we would like to know that. Yeah, we can take this. This is length. Now, while you are going to calculate that its density, you can take that it is equal to mass by volume. So, already we have discussed about that volume. It is going to be L cube. We will take that is m by L cube. Simply you are going to take that mass and volume. Therefore, density is equal to m by L cube. It is known that the density is going to be identified. Yeah, rho. Density is represented as rho. Now you will take that m power that 1 and minus 3. These are the dimensions of the base quantities. For mass it is going to be 1. For length it is going to be minus 3. It is very clear. So the dimensions are positive or negative, or it may be 0 also. Sometimes you can get this one also. It is very clear. Now if you are going to take that area, that is of L square, the dimension is 2. It is very clear. Now let us go for another one. Yeah, you can take that measurement volume. If you are taking that volume, and if you are going to take that area of the sphere also, for any physical quantity its dimensions are going to be calculated. You can easily find out that. Here you can identify that. Yeah, if you are taking that r radius, that r is equal to identified some L, let us assume, yeah, it is going to be 4 pi L square. Yes, in that one the dimensions of length L is 2. It is very clear. Let us go for another one. We are going to take that sphere or any object that we can take that. If you are going to take that one derived quantity, if it was expressed in terms of fundamental quantities, the fundamental quantities are going to be raised to a particular value. that value is identified as a dimension. So let us assume this is a sphere, this is a, you can find out that circumference also, you can find out that area. Now it is very clear, if you are going to take any object, its dimensions are going to be measured. For a physical quantity like that, force, acceleration and displacement, whatever it may be, all the derived quantities are going to be identified. Here let us assume that if you are going to take that force, it is equal to mass into acceleration You can take that. While you are going to take that, this is a one fundamental quantity. This is a fundamental quantity. Yeah, this is derived quantity. Please take that. If you are going to find out that dimensions of this physical quantity, you can take that acceleration. Yeah. That is rate of change of velocity. If you are going to take that velocity, it is one parameter which depend on displacement and time, by time. Now we are going to look into the matter of that length, which is used to measure the displacement, and the time is a fundamental quantity, length is also fundamental quantity, and rate of change, it has been identified with respect to the time. It's very clear. Now acceleration is equal to, acceleration is, it's going to be A is equal to d by dt of v. Simply we are going to take that. So v is equal to displacement by time, that is v can be identified, v is equal to L by t. It's very clear. Again, if you are going to take that L by t by, you are going to take that L by t and t. So acceleration, it is identified as A is equal to L by L into t minus 2. L into t minus 2. It is very clear. Now you can take that. Now, we finally have been obtained that dimensions for time and length in case of acceleration. And if you are going to take that, this is m power 1 and L into t power minus 2. Right. Now clear, that is m L t minus 2. Very clear. You can easily identify this one. What about the dimension of mass? What about dimension of length? What about dimension of time? That is, you can take, this is 1, this is 1, this is minus 2. In this way, we can represent the dimensions of a physical quantity. It's very clear. You need to know that the derived quantity has been represented by the base quantities, or it is represented by the fundamental quantities like mass, length, time. So from these fundamental quantities, you can measure the dimensions. It is very clear. Now let's go for another one. Dimensions. What about the dimension? Dimensions of a physical quantity is nothing but the powers of a base quantities are rise to a particular value. You can take that. The base quantities are rise to represent the quantity. Suppose you know base quantity. What is a base quantity? This is a base quantity. say L. So, to represent the area, suppose if you are going to take that, in order to represent the area, that is the base quantity raised, power raised, it's going to be raised to 2. It's going to be raised to 2. Yes, it's very clear. Suppose if you are going to take that volume, it's a power, the base quantity power has been raised to the 3, that is L power 3, power raised to 3. Very clear. Now you can go for dimension. What about dimension of L? Dimension of that, if you are going to take that dimension, you can take 2 and 3 in that case while you are finding that calculation and all these things. Suppose you are going to take a one parameter like that, what we have discussed about that, F is equal to m L t minus 2. In this case, what is the dimension of mass, length, time? It is calculated, but it has been derived with the help of basic fundamental quantities. Like what about basic fundamental quantities? Basic fundamental quantities, mass, length and time. These are very important. These are the mass, length, time. These are basic fundamental quantities which are known as fundamental physical quantities. Very clear. From that we can take that derived or whatever it may be. It's very clear. Now the representation has given, yes. If you are going to take that, first you can choose the physical quantity and you can represent the formula, the physical quantity which is represented by the formula in terms of the fundamental quantities. Like what about the fundamental quantities? Length, mass, time, electric current, temperature, luminous intensity and amount of substance. It is very clear. Now you can take that length, what we have taken, length, mass, time, electric current is going to be electric current, it is going to be theta, it is going to be candela, that is luminous intensity, it is going to be amount of substance. These are all going to be symbols, dimensional symbols. We can easily identify that. If there is any formula which is related to all these dimensional quantities, now we can frame that. If you are going to take that L and T, you can take. If you are going to speed and velocity, it is going to related with L and T, that is L by T. It's very clear. Now you can take that any derived quantity which has been represented from the following 7 base quantities. Its power is going to be raised to a particular value. It is known as a dimension. Generally, how you will represent the dimension? Let's see. You can take that. You will take that example. Let us take that example. We have discussed mass by volume, density. Yes, it is good. So the dimensions of density are 1 in mass and -3 in length. You can confirm this is dimensions of other quantities is 0. What about other quantity? Generally you can take that m power is going to be 0. Now you can take that dimensions of a physical quantity either positive or negative or 0. It is having that its value. Please take that. Expression which shows the how and which of the base quantities represent the dimensions of a physical quantity is called the dimensional formula of the physical quantity. It is very clear. If you are going to take that dimensional formula which is related to that some fundamental quantities. Now, general representation of the dimensional formula, please take that general representation. If you are going to take that any physical quantity, yeah, so any physical quantity its representation is like that. Now, you can easily identify that what is M, L and T. These are the base quantities. Yeah, A, B represent positive or negative or 0, 0, 0. Yes, what are the possibilities that you can get this A, B, C values? A, B, C are the whole numbers that we can take that whole numbers, and sometimes you can take that ratio also. Sometimes you can express that. It is very clear the possibilities, positive or negative. You can take this table, which is very, very important. Now, it is very clear if you are going to take that physical quantities which are going to be identified with the power, yeah, that is M power A, L power B and T power C. It is representation. So, how you will identify this? With the help of, yeah, you can take that pressure. If you are going to take that pressure is a, yeah, it's going to be identified. So, force per area, force by area. If you are going to take that. Already we have discussed about that force. It is expressed as, yeah, force. If you are going to take that force and area, therefore P is equal to, what about ML T minus 2 by L square? Very clear. You have to, first step you need to take that formula. Second step you need to take that substitution of that particular base quantities, and if there is any conversions also in any physical quantity, just you can apply that. What happened? Let us see. P is equal to M L T minus 2 L power minus 2. Therefore, M into L minus 1 into T minus 2. Very clear. Now, this is the dimensional formula. Just you can take that dimensional formula which involves that the base quantities mass L, T. So, M power 1, you can take that M power 1. So, the dimensions of mass in that pressure, it is going to be identified 1, length it is going to be minus 1, T it is going to be minus 2. It is very clear. Now, we have obtained that the dimensional formula and its representation. Let us go for another one. Yeah. Yes. You can confirm this. Let us erase. Yeah, it's very clear. Yeah. Let us go for dimensional formula. What is its definition? Just the dimensions of a physical quantity or the powers which to rise to a base quantities, and it is going to be represented in the form of one formula, and it is going to be identified the powers which gives the dimensions, and the dimensional formula has been represented in the square bracket. You can take that. This is very clear. Dimension formula of any physical quantity can be represented in this form. You have to write. All these are based on the formulas which are involved in the derived quantities in terms of some base quantities. Very clear. So, you have the confidence to derive that dimensional formula of any physical quantity. It is very clear. If you want to take that some examples, if you know velocity, displacement by time. Speed, distance covered by time, a particular time. Acceleration, you can take that rate of change of velocity. If you know for velocity, it is easy to calculate for acceleration. Now, let us go for another case. Yeah. What about the steps involved in that case? Write the formula of a physical quantity. Step 2, formula, that is very, very important. We have written, that is, if you are going to take that formula, yeah, just you can take that second one, convert that formula into fundamental quantities, convert the formula into fundamental physical quantities, very clear. Now, step 3, what about step 3? Write the corresponding symbols or for that fundamental quantities. You are representing that the fundamental quantities symbols and all identified, you know, that is length, mass, time, and if you are going to take that temperature, light intensity, and if you are going to take that any other quantities which has been derived in terms of fundamental quantities, it can be identified. Now, you can take corresponding symbols, and step 4 is make proper algebraic combinations to get that final result. Algebraic operation means just you have to take that multiplication and division and all these things. You are going to add that algebraic operations to get the final result. Now, let us go for another one. Yes, this is a chart which is representing that dimensional formula of physical quantities. We have discussed area at very beginning. We have discussed about that area, we have discussed about volume, we have discussed about that density. Now, and speed, velocity, both are derived, acceleration, momentum, force. Now, if you are going to take that impulse, what about, do you know the phenomenon of impulse? Within the short period of the time, a huge amount of force acting on the small area. Within the short period of time, large amount of force acting. Let us take that example. If you are going to take that impulse, the case, you are hammering that nails. Just by hammering, you can grip the nails into the walls. Huge amount of force is going to be acting on that one. Small area, have you seen that nail? It is having very small area. With the hammer, just you are going to do the work in that. That is the force into time. And if you are going to take that explosion, bomb explosion, in that case also, there exists a huge amount of force in the area, small area. It was going to be explode with a huge amount of that force because of its speed of the particles. They are going to exert the force on the surroundings. At that case, you can take that. Work and energy, you can take that. If you are going to take that, now you can power also, you can calculate. If you are taking that power, it is identified work done per unit time. Suppose you have taken one motor, electric motor, which is going to lift the water. At that time, it is going to take the reference for 10 minutes or 15 minutes or 20 minutes, whatever it may be. It is going to be having that capacity to lift the water from a particular height. So, work is done by the motor. At the time, you can calculate. Pressure also, we have discussed about that pressure. Very clear, we have discussed the area, volume, and speed, velocity, and acceleration, and all the parameters are identified. Momentum also, we have discussed that. Let us go for another one. Yeah, convert the density into desired units and find the dimensional formula. Yeah, in this conversion, you can take that 1 gram, yeah, 1 gram by 1 centimeter cube. It is going to be converted into kg. How it is going to be converted into kg? How it is going to be converted into it's going to be meter cube. You have to take that. Yeah, please have a look. Suppose you know one thing, that is 1 gram, it is going to be represented, yeah, that is 10 power minus 3 kg, and you can take that 1 centimeter, it is going to be, initially if you are having that, yeah, if you know that 1 gram by 1 centimeter cube, it is going to be converted in terms of kg, that is 10 power minus 3 kg by 10 power minus 2 whole power 3, 10 power minus 2 meter whole cube, that is 10 power minus 3 kg and 10 power minus 6 meter. If you are going to take the 10 power minus 3 into 10 power 6 kg per meter cube, very clear, you can take that, this is the value, yeah, we can express that value, no need to get, please take that, that is 10 power 3 kg per meter cube. It is very clear. Now you can go for another one. And dimensional formula also, we have discussed about that dimensional formula. It is mass by volume, the dimensional formula, that is going to be mass by volume, you can take that, it is going to be taken as m by L cube, that is m L power minus 3. Now we have converted into the desired system, that is CGS, yeah, it is going to be CGS system to K system, we have converted, that is grams to kg and centimeters to meter. At the same time, by knowing this formula, we have derived that dimensional formula, yeah, that is ml minus 3. What about t? There is no relation, just you have to get t. T power is 0. There is no involvement of that base quantity time in the volume. That's what we are ignoring, that. We are ignoring that value, right. Now let's go for another one. So in this case, what we are going to? We are going to talk about that speed, rest and motion while you are going to take that. This is a one platform, railway platform. It has been covered the length in a particular time, the object or the train which has displacement in one direction, and you are about to know time is also one important parameter, and distance and displacement. We are going to talk about the distance and displacement. Why you have taken the displacement, you will find out that velocity. While you have taken that distance covered in a particular time, that gives the speed. Very clear. Now let's see, you have to confirm, this is a one physical quantity, we have to know that, it's very clear. You can take this, yeah, what you have been observed. There exists a motion, one person is going to observing that he was in the rest position, but another one, that is train, which is in motion. So rest and motion both are relative. In that case also we will take that. This is one case, we have to calculate that speed. We can calculate the speed also. We will calculate that speed and we will calculate that velocity. Yeah. It's very clear. If you are going to take that, an object which is in the motion, just you can find out that speed and velocity, and how you will confirm that it is in motion or it is in rest. With one reference, you are going to take that with the help of one reference. What is that reference? You can take that here. Yeah, the train which is going to moving with respect to that one person, he was observing that it is going to be moving. The position is going to changes with respect to a particular reference point. Yes. Now you will find out very easily. In this case, you can take the length or the distance covered by the train, and while it is going to moving in the one direction, you will confirm that in the straight line path, you will confirm that displacement. You have to choose that displacement, and that gives the velocity. It's very clear. Now let's go for another one. Yeah, convert the speed. Just while you are talking about the speed, that's what we have taken, that how that speed has been estimated. You have discussed about that. Can you guess that the speed of train? Probably it may be having that 80 km per hour, generally based on the condition. 80 kilometers, 90 kilometers per hour, whatever it may be. Just here what they have given, the speed into desired units, and find the dimensional formula of the speed. Yeah, please take that. That is, convert 1 kilometer per second into 1 meter per second into kilometer per hour. So in the problems, in the examinations, if they have given the problems, now you can take that. So given data might be in the SI system or CGS system. Please look into the matter. Even though if you are going to take that in this given problem, you are going to express that higher order priority and lower order priority for that one. So kilometer per hour, meter per second. Simply you will take that. It's very clear. You can easily find out that. You can easily calculate that 1 meter per second. It is taken as kilometer. That is, you can take this one. Yeah. So you know very well about that. 1 meter is equal to 10 power minus 3 kilometer. Simply 1000 meters is equal to 1 kilometer. Yeah, 10 power 3 meter is equal to 1 kilometer. Yes. Now you can take that 1 meter is equal to 10 power minus 3 kilometer. It is very clear. While you are going to talk about that time, it is going to be time. It is going to be taken as second into hour. Very low value. Low. In the representation in terms of second, it is going to be converted into hours. You know very well about that. You know, 1 hour is equal to 60 seconds. Sorry, 1 hour is equal to 60 minutes. Yeah, 60 minutes. Yes, therefore, is equal to 60 minutes. This has been converted into 60 seconds. It's very clear. Now you can take that 60 seconds. Yeah, 1 hour is equal to 3600 seconds. It's very clear. Now you are converting that kilometer per hour. Meter per second is going to be converted into kilometer per hour. It's very clear. Now easily you will change that. Yeah. Based on this conversion, we have been calculated that, yeah, 1 meter per second, it is going to be converted into 18 by 5. It's very clear. Now let's go for another one. Its dimensional formula is going to be L power, yeah, dimensional formula, it is L by T, that is LT minus 1. It's very clear. Now you can easily find out that basically you have to know that relation. From these relations only you will get that conversion. Suppose if you are going to take that kilometer per hour is going to be represented in terms of meter per second, yeah, you have to take that 5 by 18. That is the multiplication, just you have to get multiplication with 5 by 8. It is very clear. Now you can take that, yeah, convert 54 kilometer per hour into, yes, meter per second. Just we have to take that 5 by, yeah, while you are going to converting that kilometer per hour into meter per second, just you are going to get that 1000 and 3600. You are going to 1000 meter 1 hour by kilometer by 1 hour. It's going to be taken as seconds. Just you will take that, that is 5 by 18 meter per second. It's very simple. Easily you will find out that conversion. At the same time, dimensional formula is also going to be calculated. Yeah, into centimeter. It is very clear. Easily you will find out that. Now you will get that centripetal force and all. So the force which is related to the parameters. Yes, you will take that. Force is also going to be finding that mass into acceleration, mass of the body, which plays important role, and the velocity, rate of change of velocity, all these parameters plays important role. Okay, all of you, thank you very much.